So, welcome to another episode of the Business of AI podcast, and I'm delighted to be welcoming Linda Hong Cheng to the latest episode. And Linda, it's great to have you here. I'm looking forward to talking to you.
Yeah, it's an honor to be here. Thank you so much for inviting.
Yeah, we've had a number of interesting conversations over the last few weeks, and I'm really fascinated to open up on some of those topics because I think some of the work you're doing over in Oxford and some of the businesses you've been involved with, it's really fascinating to understand some of the cutting edge technology that you've been seeing and how you're looking at developing that into businesses and spin outs and companies that can scale. So I wonder whether you could start off by telling us a little bit about your background. How did you get into what you're doing today? And tell us a bit about what you are doing.
So I come from a really eclectic background. I started out in economics and history at UNC Chapel Hill, and I was doing a lot of stuff with like mathematical models and a little bit of game theory, a lot of historical work. And then I actually ended up pivoting because at the time I thought I'd be a China studies professor for the longest time. And so I ended up pivoting to computational methods on social science topics when I went into Columbia for my master's. So I got a scholarship to Columbia, studying the regional studies program under the School of International and Political Affairs. And that's when I sort of first had my, I guess, first interaction with AI. And that was, I think I was among like the first cohort of AI and ML researchers. And so at Columbia, I utilized natural language processing, like sentiment analysis, for instance, or structural topic modeling, which is like a thing of the past now, and machine learning on big social media data from mainland China to analyze protest events and socioeconomic unrest. And that was like my first sort of instance of using AI. And I became really fascinated with the use cases and applications of AI for modeling complex systems and disruptions within complex systems. And I guess like that is sort of the beginning of what has become like a huge, trajectory for me. And I ended up becoming the youngest invited author for the Oxford Handbook, writing on decolonizing or diversifying computational methods for non-European languages, because I noticed when I was analyzing a lot of Chinese language text and big data, a lot of the methods using applying sentiment analysis, for instance, necessitated making the data and the language within that data, social media data or text data, more like English or European languages so that it could become analyzable by the algorithms. And, I was like, this is just, this is not fair. It's a flaw in the existing foundational level. And so I published two papers, sort of in computational social science, and I ended up coming into Oxford studying computational demography. And so it's a continuation of that work, but on a more global scale. And then, I guess since then, I've just gotten really into the applications of AI for complex systems, and I sort of expanded beyond just socioeconomic applications into industrial intelligence, which is how Lychee Labs was born. And obviously before Lychee Labs, I also had a few other AI ventures. So my first venture was Mung, M-U-N-G, like the bean, and that was an age tech venture. We utilized AI to support older users in being able to use their smartphones better. So like a co-pilot for older users. And that drew a lot from my demographic work on population change, for instance, right? And then the next was girl pain. So I use AI to create a small platform to uplift women artists and connect them with the global art market. Had two sold out exhibitions. Both of those ventures were covered by BBC. China Daily also covered girl pain's exhibitions as well. It was like a lot happened. It was a success, but it was also, I learned a ton in the process. And then Lychee Labs was sort of an amalgamation of everything that I had done before. Really a lot of my work intellectually and within the entrepreneurship space on how to really deploy AI and frontier software technology for dealing with complex systems and learning how to adapt to change and uncertainty and exogenous shocks.
Yeah, Great. Well, wow, you've been involved in quite a few big topics
Yeah.
there, and a lot we can unpack. Um, let's start off by following on from what you were talking about Lychee. So that's the sort of business you're growing at the moment. What does it do, and how are you? Well, who are you doing it for? Is it for businesses? Is it for consumers? And what stage are you at?
Yeah, so Lychee is an early stage AI lab born out of Oxford. And so we utilize world models, graph neural networks, multi-agent reinforcement learning on the back end to essentially help industrial manufacturers deal with exogenous shocks within their production line. So to make that more concrete, for instance, within a car manufacturing line, when there's a firmware change in the production line, that can actually disrupt the entire production of an automobile. And that costs suppliers, that costs the production, corporates millions in lost revenue, millions in lost profits, and that's something that we step in to help in optimizing. And at the larger level, if you think about a manufacturing or production line, whether it's food and beverage or automotive, any continuous manufacturing system, you see that it is like an algorithm, right? Because you have so many moving parts that need to be assembled and integrated and synthesized in just the right way, an optimal way to ensure the highest output and throughput so that these items that are being produced can land in consumers' hands. And oftentimes we're talking about steel or food or cars. These are absolutely essential to ensuring the well-being of a society and of a nation as a whole.
Okay, so help me understand how that works then. So you mentioned the production line for something in manufacturing, right? So I understand that there might be lots of different machines involved in that. There's probably a huge array of data sensors for each part of the production line. So where do you fit into that, and how are you actually able to optimize it? Are you sort of looking at creating something like a digital twin so you can understand where you can speed things up, slow things down? Or, what are you actually doing in that production line?
Yeah, so our flagship product can essentially plug into existing cells of an automobile production line, for instance, into a digital twin and tell you what happens after a firmware change, what you should be doing to recover time to recover. And so that's like quite technical, but essentially within a production line, when there are firmware changes or any kind of shock or any kind of, you could say, quality defects, that affects the output, right? And that also negatively affects time to recover. It negatively affects the efficiency, right? And so we step in and basically are helping in decision making of what to do with that production line to ensure that it returns to optimal levels or even gets better. And so it's a really small part of production line, but it's actually quite critical because we catch quality issues or firmware change issues before it goes down the line when that could cost much more money.
Okay, great. Well, yeah, that sounds you found your niche in terms of where you can fit into that whole process, and then you're using AI to be able to optimize that process. Now, I wanted to come to one of the terms you used there, world models. It's something that maybe our audience haven't heard of. I know you know a lot about it, and I'd be fascinated to get your help to understand where we are with world models at the moment, because I know Jan LeCun has been a real champion of this. He's just set up his new business looking at world models. But help us understand, what is a world model, first of all, and then how do you think they're going to be used in the future?
Yeah, so I mean, in really plain English, world models are essentially neural networks that can understand real world dynamics, right? So it can include physics like first principles of an environment and also spatial properties. So, for instance, as humans, I think that it's in the name is that we can sense what's happening in the world around us in a really literal sense, right? Like I'm sitting on a chair right now and I'm not going to fall through this chair because it's a physical barrier between me and the floor, and gravity background, so maybe I'll get cursed out by that. And that's an embodiment of a first principle, right? So able to have agents that are aware of the physical spaces around them, and that can understand multimodal data, which is ultimately the goal of any kind of model development. and going into environment. And right now, a lot of world models, they're being trained on games, right? Because games are a perfect way to simulate a real world. You have water, you have air, you have ground, rocks, mountains, etc. that new players or characters have to climb, and that's why a lot of gaming simulations have been used to pre-train robots, for instance. And NVIDIA has this. Other companies are also testing different kinds of these like gaming virtual realities. And so that's a really simplified definition of what a world model is. It's something that lets you understand the world, right? That's something that takes in the different governing laws of the world that we live in.
And I think this is where it becomes really important. And, I've heard Jan LeCun speak about this as well. He compares it to the way a baby learns, the way that we as humans learn when we're babies. And we don't just learn text, we don't just learn lots of sentences. We actually learn, like you say, about the physics. If you drop something, it'll fall. If it falls on our foot, that's painful. It learns all those multimodal, multi-sensory ways to understand the world. And that's kind of important in a number of ways, because then actually when you're trying to understand and make proper predictions about you as a human, how you're going to interact, you can draw upon all that information. Compare that to a large language model, which is very unidimensional and it only looks at text. And so yes, it's very good at being able to predict text, and amazing in terms of some of the results that we can see around us, from all the LLMs when we ask questions. But it won't be able to go to that next stage of really being able to bring all that in. And so, how are you using these world models within what you're doing?
Yeah, so we use world model architecture at an industrial scale. So we build live graphs of plants, machines, SKUs, constraints using graph neural networks. And so this is really different from digital twin visualization because we build essentially a decision engine that can run multi-objective optimization and reinforcement over these live graphs, right? And the graph is just mapping out, what's happening within a plant. And the constraints are essentially the world that the models are being trained on to understand. And then the question that's being answered constantly is, given everything that just changed, what's the best thing to do next? How do we deal with this exogenous shock? And that's that's one of the core components or core missions of a world model, is to be able to train that on essentially the real world, the workings of the real world, the parameters of the real world that we live in, which is on Earth, right? And then to predict future states based on that, which is ultimately, that's just really, really simple and clear mission that we're applying to industrial intelligence.
Okay, really interesting. So it definitely feels like world models are going to be something which we're going to hear a lot more about in 2026.
Absolutely.
And I also wanted to kind of ask you about something you mentioned earlier on when you talk about your sort of background in terms of the way in which you're looking at decolonizing and opening up some of the models because they have a very large representation from European languages, but they don't do so well on other languages across the world. And there's this concept in philosophy of linguistic relativism, which spawned a whole kind of debate around whether the actual language determines thought or constricts thought. And I wonder whether it's the same thing we're seeing here with large language models, where they're actually based upon European languages, so they have a very specific structure. And then not only are they restricting what people from other languages can do, but also they're restricting the way in which the thinking, in quotation marks, happens within those models. But could you elaborate and help us understand a little bit about your work in this area, and what were the key problems?
Yeah, absolutely. I'm really glad that you brought this up really specifically. I think that, to get really, really abstract, like all of the structures that we are seeing in the postmodern world, a lot of them are built on, historical institutions, movements, whether it be colonization, imperialism, etc., as well as, different kinds of traditions, disruptive or organic to that region or to different regions. And that influences the way that we interact with our languages, with our cultures, with our new methods of organization and structuring of our institutions, right? And for instance, one really basic example is like the way that capitalism has structured the way that we live, the way that we think, and the way that we shape our values, right? Making money and consumerism, and how consumerism orients status and class, etc. And it's the same with language, right? Like a language is an entire worldview. It's a cosmology or a view of the universe. The words that you grew up learning and how you define them and relate with them, and what they mean, the sentiment that they carry, the value that you assign to them, this shapes how you view the world, and ultimately it shapes how you build systems and how you create, right? And so natural language processing methods, they're built by Anglo-centric or not English-speaking people. And so they're built for English, and the logic and way in which that they work is going to be centered around that. And I mean, even to get like a little bit more philosophical, though, the epistemology of how these frameworks have been built at a really abstract level has also been shaped by the way that English is formulated, right? Not just in terms of like adding spaces between every word, but the way that words are weighted, and the way that sentences are made and analyzed within these models, because natural language processing transformers, they're sort of the basis of large language models today, right? How they're analyzed is following that logic as well. And that's a very different worldview, right, than that of, say, Chinese, right, which is probably the oldest language in the world, and has a lot more, I would say, there's just exponential richness, but also historicity and complexity in a way that might have changed if things had been developed based on Chinese or Arabic or another language, for instance. It would have changed the frameworks in which language itself or the words are weighted within these algorithms, which would downstream have ripple effects on how these models think.
Yeah. I mean, this is all fascinating stuff, right? Because I was writing down a question then, which is, are there now models which are generating I don't know whether you call it the taxonomy, but basically the structural way of interpreting language, which is more based upon other non-European languages. So is that happening? I mean, and I'd be fascinated to know. I mean, I feel like I should know this, but around DeepSeek, when they built DeepSeek, did they actually use a model which was based upon the taxonomy of the Chinese language, or as many suggest or have hypothesized that they actually just used what was in some Western models, and they kind of adapted that by putting some Chinese language into it, and therefore would have had the taxonomy from that Western model?
Yeah, I would say that, DeepSeek represents definitely a breakthrough in the space because of its edge deployment capabilities. So it developed models that can distill and deploy in a sovereign capacity, right? And so in that sense, DeepSeek definitely did represent disruption. There are definitely edge models in a lot of countries that are based on non-European languages, and that's, I think, a really great improvement from a lot of the ChatGPT centric or other Western model centric reasoning frameworks, right? And I think there are two sides to this. So one of them is more in the infrastructural level, right? So whether or not models are being operated by people who aren't in the West, or people in countries considered part of the third world or global south, or sort of disadvantaged countries. And that kind of AI sovereignty is really, really important for having control and autonomy over the data that's being trained in the models. And so, for instance, indigenous folks can actually maintain autonomy over the data that's trained within models that they develop, so that they actually can build trust with the technology itself, and they can also shape it in a way that is serving their community. So that's on the infrastructure level. And I think the other end of that is more cosmetic, which is what I was maybe more so talking about, and cosmetic in a relative sense, in that, what language the model itself is being made of, and the algorithms that are actually being created, the logic of that. And that obviously relates a lot to, what community or what group of people are in charge of developing these models. And so, yeah, there are, more, I would say there are more models now that have multilingual capabilities beyond European languages, that are trained on massive data sets across languages. And a lot of these examples are from mainland China. So like DeepSeek V3, I believe they use 14.1 8 trillion tokens across multiple languages. And then there's Qwen, so QWEN, which is Alibaba's new. It's a pretty frontier model that I think it's trained on 120 or I need to look it up. I think it's 120 languages, and this includes like languages that have not traditionally been included, including like Burmese and Thai. And then these models, and I've used a few of them, they can really naturally handle dialectical variations within Chinese. For instance, I think there are a few hundred dialects across China, right? There's Cantonese, there's Hokkien, slash Fujianese, slash Taiwanese. There's Kejiahua, there's like Shanghainese, there's a ton of dialects, and there's Mandarin, right? And so they can really detect these in a very fine-grained manner. And so that is actually quite amazing. At the same time, though, I think that it is notable that most of the models still, like, I think it's great because when I was writing my paper, and that was many years ago now, and that was when AI was still not really a thing. So I remember writing the Oxford Handbook chapter. I had to define what artificial intelligence even is because no one really knew what it was, and that was really funny because I look back now and like everyone's talking about it now. But at that time, there weren't really many anything beyond a lot of like European sort of packages to use within like R or Python to do natural language processing on like a non-European language. There are a few packages like Jieba, and there was BERT. That was a transformers kind of thing. But these LLMs hadn't existed. They hadn't really been big. I think ChatGPT 3 at the time was like existent. But now, I mean, most of the AI market is actually dominated by either American trained models and or Chinese. I think Chinese models actually dominate like 30% of the world AI models, and so a lot of the landscape has changed. And I do think it's amazing that Chinese models have come and become really big and made a lot of leaps and bounds. But like we also shouldn't ignore that there are still a lot of languages that aren't necessarily where the people of those countries aren't necessarily building their own models, right? And so that will always come with its own gaps.
But I'm trying to think about what the limitations are for these other languages within the existing models. Because, for example, I've used ChatGPT to translate from English into some other languages. Now, from what you're saying, that should work for European languages, so that makes sense. But I've also translated into Quechua, which is spoken in South America. It's an indigenous language that doesn't have this sort of European structure. And kind of, I don't know Quechua, but I wanted to understand a few basic words and phrases, and it gave me those. It seemed to understand. So it has had some training data in all of these languages to be able to output something. But I suppose, are we saying that it can only get to a certain level, and that beyond that, it's not going to have the same level of detail structure that you'd see if you were to ask it a question in a European language?
Yeah, I think my perspective is approaching this from more of an AI researcher's angle, which is that these models that are English centric show noticeable degradation when they generate content in non-English languages. So there are cultural misinterpretations, grammatical inconsistencies, and limited idiomatic expression, especially if you want to get into more depth using that language, or if you're using that language literally to communicate with a model. And that's where it reaches, you could say, a limit, like an upper limit, right? I think in like sort of normal plain translation, it probably has a lot of the basic components that are needed for something that's more fundamental. But in terms of actual benchmarking, then that's when they start to degrade. And that's definitely an issue, right? And these performance disparities between English and non-English capabilities is something that a lot of other scholars have pointed out is in the AI language divide. And there are lots of divides within AI, just as there are in all of technology and I mean all of society, right?
And what's the consequence of that, though? I mean, we're talking about the fact that there are more language models which are based in English, definitely, and in European languages, a lot of the structures kind of benefit that. But there are now a few in Chinese. But what's the net result? Why is that a bad thing? And does every language or every sort of zone of the world need to have some of its own sort of language models to be able to compensate for this? What's the output? What's the problem?
Well, I think the AI divide in it of itself, I mean, from the point of just resource allocation, right? And the issue of accessibility is really important for people in these countries that aren't represented, or their languages aren't represented by LLMs, or they're not able to perform at the same level as English, because this again reinforces the fact that English speakers will be, given more resources in terms of learning and accessing a lot of the information that is provided from LLMs. And of course, as the world increasingly integrates LLMs into different processes, there's obviously a lot of pushback against that within the academic sphere, but different classrooms, it's become a huge advantage to be able to use it. Then that presents another sort of disadvantage for essentially not being of English speaking capability and you trying to use this kind of technology in a non-English language, right? And that basically on a high level is just a form of linguistic gatekeeping, right? Because you're only able to access certain information or certain kinds of technological capabilities when, well, you need to have a good working computer with a good GPU, which again is already something that is stratified unequally. But then number two, say you have access to that, then there's a linguistic sort of divide, right? And so if you don't know English, or you want to communicate in your native tongue, but the model's underperforming in that sense, or in that language, then you're disadvantaged just from the get-go because of that.
Yeah. Thank you. That's been really helpful, and it's been fascinating, really, to think about the consequences, the sociological consequences of the technology which is being built. And I think it's one of these examples where when people were building the technology, they weren't thinking about the consequences, and now we're at that stage where it's become so adopted across the world, and it is starting to have consequences. But thankfully, people are taking notice of this. Well, we're going to have to start to wrap things up. But just as we start to wrap things up, I wanted to ask you, from everything you're seeing and working on, what are the things that you're most excited about as you look at 2026 and the year ahead?
Yeah, I would say I'm that's a great question. I would say I'm most excited about pushing towards truly adaptive intelligence from the models that we're building and deploying within these manufacturing production lines. I truly believe that integrating sensory data and this kind of data from manufacturing production lines into our models will enable them to become much smarter, essentially. And something that I'm really big on, and something that Lychee Labs has a really big commitment to in terms of our mission and vision, is pioneering adaptive intelligence, so that models aren't just predictive or static the way that not large language models are, or even world models. I think they continue to be anchored in that kind of logic, but are able to improvise within unknown settings and complex systems that face unexpected shocks. And what better place to test this than within a very fixed kind of environment like manufacturing, where there are hard parameters. And so it's an easy test bed to begin with. It's a good first instantiation of that, and really building a canon around this, because ultimately, as an AI researcher, I am very fascinated by cognition, and that's really what drew me to the field to begin with. Is it was a marriage of machine and human intelligence, right, which is cybernetics. And really, if we think about humans, our most powerful form of intelligence is the ability to improvise, to learn through play, and to learn through silliness, right, and to learn through adaptation. Our ability to adapt is what keeps us alive as a species. Whether it's sort of recovering from heartbreak or shocks or bad things that happen to you, or being able to have that ability to have metacognition, to reflect and to criticize yourself and to change, and to evolve and adapt and improvise, right, throughout life and in specific circumstances. And that kind of intelligence is something that really makes us sentient, and I'm really, really excited to see that come to fruition within the models that we're building, and to really instantiate that in a way that to deploy it, in real world settings in a way that actually makes production lines, manufacturing more sustainable, more reliant, more resilient, and safer, and just better for societies and for countries as a whole.
Yeah, it sounds fascinating, and I love that sort of that concept that you included there, that it's what makes us human, being able to be adaptive.
Absolutely.
But then we're talking about taking that quality and trying to recreate it in machines. and allow them to be able to display the same processes, so that we, for the same inputs that a human would recognize, then give the same, if not better, outputs. And that sort of brings us to, I think, talking around artificial general intelligence, and even super intelligence. So in what you're doing, you seem to be building something which might actually help get us there, right? Because you're using world models, so you're going beyond just what we've got at the moment with the LLMs, and you're talking about adaptive intelligence. So do you see that being part of the path towards AGI?
I do, and I hate to be, someone who is also like a tech bro saying, "Oh, we're gonna achieve super intelligence," but from the perspective of someone who's been in this space for quite a while now, I believe that the safest kind of AI that's being deployed in the real world will be also the most intelligent type of AI, right? We don't want AI that hallucinates. We want AI that can take into account its surroundings, physical surroundings, and also being able to, be reliable in really important settings, whether it's manufacturing or in safety, defense tech, etc. And I definitely see what the work that we're doing at Lychee as part of, a really, I think, special group of people in the world who care about this a lot, right? Pushing the needle forward, and also doing it in a way that is, safety first, and very much so, I think, aligned with values of resilience rather than hype, and augmentation rather than replacement. And that's something that's really important. I also run Gossip Group on the side. So it is a global invite-only network for founders, investors, and operators. And one of our through lines for Gossip Group is really investing and backing companies that are making the future healthier and happier and more human. And that remains one of my core philosophies as well, is that ultimately I want the work that I do to obviously contribute to innovation, but for the sake of making the world healthier, happier, and more human. And that includes making our technology more human-centric by modeling, I think, the best parts of human intelligence.
Fantastic. Well, I love what you were saying there about really sort of doing this with a purpose, and
Absolutely.
actually trying to sort of find the role of technology to augment humans. But also, I think, because rather than just doing AGI for AGI's sake, right, which is, what the tech pros are constantly talking about it coming, you've actually got a really specific use case here where you're applying the technology within manufacturing to help optimize that whole process. So you've got specific outputs and specific results, and you're going to help to improve that. So yeah, that's been it's been great. We've covered such a lot of ground. We've gone from talking about languages and quite a lot of philosophical concepts there. We've covered world models, which was great to hear you articulate how you're using those. And we've talked about the practical application of these technologies as well. So there's a lot we've covered there, and we've even got onto AGI at the end, which is amazing. So Linda, it's been great to chat to you. Thank you so much for joining me today.
Yeah, pleasure's all mine. Thank you.